Hello everyone, today I will teach you how to compile Linux Kernel 5.4.2 and with a new system core. My operations will be done under Ubuntu 18.04 in VMware. So let's start. Let's install Ubuntu 18.04 in VMware. So I will be using the Windows version of the VMware Workstation, and you can easily download it from the internet. And as how to crack it, you can simply search VMware Station crack on YouTube. Yeah, and then let's create a new virtual machine. So let's choose typical and choose the Linux image that you have downloaded from the internet. So in my case, I will be using Ubuntu 18.04.3 desktop version, and it is AMD 64. This can be easily downloaded from the internet. So you just go to google.com and then search Ubuntu 18.04. And then you can download it from the official website easily. So simply click on download and the download should start. And after the download, you can use the VMware to install it. Just choose this image and then choose next. And then enter a full name, username, password. Let me see. So my name is Feng He, and so Feng He, and then 1, 2, 3, and then 1, 2, 3. Go next, and then choose a place to store your virtual machine. I will call it 1, 2, 3, and then next, and then allocate space for it. To compile the kernel, you need more space than 20 gigabytes, I think. I think you can choose 40 gigabytes, and then store the virtual disk as a single file so that the performance is always the best. And then next, and then to make your compilation faster, and we can change the memory size and the processor count numbers. So since I have 62 gigabytes of memory, I can easily choose 16, and then we can choose processor like 8 processors and 16 cores. And if you want to access your virtual machine in your local network, you should customize the network adapter. So I will choose a customized virtual network so that I can access it with SSH from my Mac PC. So the Windows machine you see here is not an actual Windows machine. This is a remote desktop via the local network. So I have this one micro remote desktop installed, and then this is a machine that is in the local network, and I have access to it, and this machine is used as a server. And this machine is always used as a Windows server by me. So you can choose a virtual network and then close it. So to be more specifically, this virtual network can be edited here. I will not use this one since I have already one installed so that our speed is faster. So what I wanted to mention is that you can edit your virtual network adapter here. So I was able to edit it as virtual network 0 is because the virtual network 0 is already associated with my PCIe gigabyte network adapter. So that's it. And then let's access this virtual machine. So to make our life easier, I think it is better for us to use a Linux virtual machine via SSH. So using a virtual machine directly via VMware can sometimes be inconvenient since it sometimes can stuck since it's virtualized and that is not like a real machine. So to make that better, we can use as a um, remote server. So let us first access it. So sometimes you may have to press the number lock key before you can enter a password, since it is sometimes locked. So I will press it and then enter my password. The security of the password can be strong or can be low. So I just choose 4 digits so that I can easily memorize it, and this machine is only used for demonstration, so no security is concerned. Okay, enter. Okay, so let's go to terminal. And to see the IP address in the local network, I will use hostname -I. Now I know that the IP address of this one is 192.168.50 and 190. Okay, I will use it to access it. So if you just use it on this machine, you can just use Windows command prompt and then use SSH root. No, not root. Since the username here is Fenghe, so I will use Fenghe at 192.168.50.195, and the default port is 22, so I don't have to use -p 22 to specify the SSH port. I will just use it directly, and then I should enter the password. The password will not show as you enter it, so that no one knows how many digits you use for your password to guarantee the security of your password. Okay, and then I've entered it, so I can easily use it on a Windows machine. Okay, now I will not use it on a Windows machine, so let's just exit, and I will set some port forwarding in my router so that I can access it from a bigger local network. We will go to WAN in our router, and then here virtual server port forwarding, and I will use Ubuntu demo SSH, and then the port from outside access will be 222. That's fairly good. And then the local IP will be this Ubuntu. Let's see. Yeah, let's see. The IP address is the last one is 195. Okay, here it is 195. Okay. And then port 22 should be forwarded to port 222 so that I can access from the outside without conflicts. Okay, add this one and then apply. So now from a bigger LAN, since I use a reverse VPN to access this machine, so I don't have direct access to this router or to this virtual machine, so I have to use IP address in a bigger local network. So I will SSH with 10.110 and then 2.108, and the port is 222. Okay, it should be set to go, and then yes. Yeah, now we have access to this machine. Now let's start the compilation of this machine. So you can refer to this post on my blog. I will have this link under the video, and then let's start. Okay, so let's firstly download the latest kernel. I think this is not the latest kernel right now, so let's go to the kernel.org. Okay, so the latest stable kernel is 5.4.6. So I will just use this one. So it is here. Let's copy the link of it and then use wget Since it is in China now, I think I should do something special. I have got to um, use a shadow socks to make it have access to the global internet so that the download speed is fast enough for me. Okay, I will make it a gaming mode and add this rule and save and apply. Yeah, so some of the sites are blocked by the Chinese government, so I have to bypass the Great Firewall to download the image from the free internet. Okay, and now I think it should be fast enough to download it. Yeah, as you can see, the download speed is fast enough. So if you have a fast internet access, so you can download it within like 30 seconds. Yeah, since the kernel image is not that large. Yeah, only a few seconds left, and then let's see what's the next step. Okay, the next step is to um, move this kernel image to your home directory, and I think it's already there, so we don't have to move it here. And let's remove this Linux link here, since I will use 5.4 instead of that one. Now let's compress it with tar. So this file name is not right, so I will have to use this command. So you have to check this command before you use it, since this may not be the name of your kernel, since here it is 0.6 instead of 0.2. Now it's uncompressed. To make our access easier, let's make a soft link. Link this Linux dash 4.5.4 0.6 directory to Linux. Okay, so we have a Linux soft link here now, so we can access it with just with cd Linux. Okay, so much better. So the operations I use later will be the same as yours, since I use a soft link Linux, and then the directory for all of us will be Linux, and instead of something like a Linux dash 5.1, a Linux dash 5.4.6. Okay, so let's install the tools that we use for compilation of the Linux kernel. This should take some time, and enter the password. Yeah, you are safe to go. Yeah, it should take quite some while, since there are like 700 megabytes of data to process. So this is just a reminder that if you meet some errors like this one, it tells you that GCC is not found, so you have to install GCC yourself. So these may not satisfy all your requirements if you have a different version of Linux, or the Linux version is just a little bit different. So just keep in mind that if something happens, you should read these error reports. It might be tedious, but you have to read it so that you know what you are missing, and you can apt-get install it. And if you are missing something like Flex, you need to install it. These are the ones that I found missing when I was compiling my Linux kernel. And after this one, I think it is time for us to apply the old configurations to our Linux kernel. We will use the information or the configurations of our old Linux kernel. Say here, it is 5.0.0, so that it won't have any conflicts. Why we use it is because that we are running our Linux system on a virtual machine, so the virtualized environment can be different from a physical one, and you manually configure it can be really tedious, or it can be really hard. So we will just use the old configurations of the Linux operating system that we are running. We will use the original one and add some, and the new ones will all be default. So we use yes command here. Autoconfig will prompt you to enter yes or no. So what the yes command basically does is that it fills all the answers with this one. So what is this one is? This one is an empty string, so it is equivalent to use the enter key on your keyboard, so that everything is applied using the default settings. These installations are done. Now let's go to the next step, and we are already in the Linux directory, so we don't have to use this command, and we will use this command to clean the compilation tree. So make mr proper, okay, and we will use the configuration file in your current Linux kernel, and we will apply default options to all the prompts. So what I will do in this tutorial after this preparation is to add a customized system call. I will print out the number of page faults of the whole system, and then print for the current process, and I will also print out the number of 30 pages of each process. So to do it, let's firstly add a system call to the 64-bit table. So let's scroll down, and here we can find a vacant place, so we can insert here. Since our system is 64-bit, we can just insert it here. So remember to press the number lock before you enter, so that it won't be run. Okay, and then this is a common one, since there's no specific requirement for our program, and I will just call it as you can see, just call it my Syscall. Okay, that's it. And then let's also modify the 32-bit table so that our kernel is compatible. Let's just scroll down. Yeah, scroll down, and I think it should be here. So just insert it at the bottom of the file, and to note that to use Vim, you have to press I to insert something. Okay, and then I386, and then this is called my Syscall. You may find that the number here is 428 and the number here is 436. Since this is an older version, so the number of syscalls of a Linux kernel can increase as it is more and more updated. Okay, and then we will use IA32 sys, and then my Syscall. Okay, and then use BSC to quit the insertion mode, and then colon, and then X to save all the changes. Okay, and then we need to add a macro in unit STD file. So let's go to the end of the file. So use colon and then the $sign to go to the end of the file, and then use K on your keyboard to scroll up, and then you can find here we add our system core number here. So we will just use define 436 Syscall and R my Syscall my Syscall. Okay, and then change the total number of syscalls to 437. Okay, and then esc:(x) to save all of it. Before that, let's check. Okay, check finished. Let's go. And then we should add the counters for page faults. And then we should add this one to the end of the file so that it's global. And then here we should press I and then extern unsigned long pf count. Okay, and then quit it, save, and then we use this command to add our variable instruct info. We can search it using the question mark and then task struct. This is not the right one, so we will use shift plus N to find the next one. Okay, that's here. Okay, so as you can see, for reasons of header soup, see current thread info, this must be first element of test strat. So we are not allowed to add our variable here. To make it safe, we should scroll down and down and down. I think, okay, it should be here. So new fields for test strat should be added above here. So they are not included in the randomized portion of the test strat. So we should follow this rule and just add our variable here. So our variable is unsigned long pf. Okay, this is the number of page faults. And then save and exit. And then we should initialize the two variables we have just added. So we should use vim and go to this directory and find this file and edit it. Okay, let's find dupe task struct. Not found yet, so we should hit enter and then use shift and N. Okay, and find the right one. Yeah, it's here. Okay, so let's go down with the J key on the keyboard and go down. Yeah, it's here. So it first checks if TSK or task is got from allocate task strat node. So we should insert our code here after this operation so that TSK is not now. Okay, so we should use TSK pf equals to 0. So we initialize it here, edit here. Now let's search the do page fault function. Whenever a page fault is found, we should increment our counting variable. Yeah, so we should firstly do a forward declaration unsigned long pf count, and then the pf count global can be used since it is an external variable, so we have to use this one to forward declare it so that it won't be run. Okay, and then we should increment our variable here. Okay, so pf count self increment, and then current pf count ++. So pf count is the global one, and current pf is the local one. This is for the current process, and then we should close this file and then go to sys.c and go to the bottom of it and insert our function. So this is our Syscall function. We should copy and paste it here, and then make sure it is the right one. Yeah, I think there's something wrong here. So the post is not updated yet. I've already updated it, but it is on the CD and content delivery network. So we should change S to I so that there won't be an error, and then we can save and exit. Wait, before that, we should I should tell you why we should use this. Okay, so let's go to the references about how to add a new system call. So there is a convention here. So let's see. Yeah, as you can see. So config function is optional, and we should use this syntax for the entry point of the function call. So we use this manner. So this function definition should not be like a normal one. So we should use this macro in Linux for Linux Syscall functions, and the function name should be here, and the parameters of the function should follow here. So just like this style, and the corresponding prototype should be in Linux Syscall.h. So just as I stated here, we should go to Syscall.h to add a declaration for it. Okay, let's see what to add it. Let's just go to the end of the file and then go up, use the K key on the keyboard, use J to scroll down, and then insert. Let's just copy this one and paste. Okay, and then colon and X to save it. And one last thing is to add this fallback stub in kernel sys underline and I.C. Yeah, this is important for compatibility. Maybe not necessary, but for compatibility, let's add it. So let's go to sys underline and I.C. Okay, so let's just go to the bottom, and then how about edit here? Okay, so let's add our compatible syscall, and then all the configurations are done. Let's just use make ML proper is already run, not necessary. So just use this command to compile our Linux kernel. Yeah, and the make program is already running. So use no help. Make sure that if my connection is lost, the compilation is still running at the back end. So let's see, cat no help.out will just output your compilation result, and as you can see, it is compiling. And since it might take a long time to compile, so for me using 12 logical processor cores, it takes me about half an hour or 20 minutes to finish it. So you have less cores or less computational power, you may need more time. So I will not wait it. Since I have an already running system, I will just exit it and just abandon this compilation here. Okay, so I will just shut down it. Yeah, shut down it. since I will not compile it right now, I will just use a compiled one. So these steps should be finished by yourself. The following steps, like sudo make modules install and sudo make install and sudo upgrade grab. You should do this yourself. I will not show it here since it might take a long time for me to wait for this make instruction. And now I will just use a compiled Linux kernel. So let's assume that we have successfully compiled the Linux kernel and have installed it on our operating system. So you have to wait for a while and then it should boot. So it should boot like this. So if this does not happen or you have to wait a long time, you may have to recompile it and you have to modify the files and then recompile it like this. This system is already boot and I will use remote access. Okay. So I have accessed this one. This one is originally 5.0.0 and the kernel newly installed is 5.1.0, a little bit from our version for demonstration, but it's no big deal. They are basically similar. Okay, so after this, let's go to the desktop. And as you can see, here it is, the test.c file. It is here. Let's see what's inside. Vim test.c. And as you can see, what this basically does is it refreshes. So this calls the system call 428. So in our 5.4.6 case, it should be 436. Since this is in 5.1.0, so the Syscall number is a little bit different. Okay, let's quit it. Assume we only have this test.c file, and then we should use gcc-o test. So this is the output program, and this is the source file we will use to compile. Don't worry too much about this, and just run our program with test. And let's see what's in the message. As you can see, the number of dirty pages of each process is listed here, and this is the process name, this is the process ID, and this is the number of page faults, the total number of page faults of all the processes, and this is the number of page faults of the current program. Okay, and now as you can see, we have already successfully compiled our kernel, and the Linux system core customized one is also working. Yeah, and that's the end of our tutorial, and thanks for your watching. If you like my video, please click on the subscribe button just below my video. Thank you.